Alright, my dear students, yesterday I taught you, this is the second lecture of thermodynamics because we started it yesterday. Yesterday was the lecture first. So before going to lecture second, we will just brush up what we studied yesterday. Thermodynamics, okay? Yesterday you studied what is system and what is surrounding. Fine? And you also studied what are the different types of systems: open, closed, and isolated. Fine? You studied this, and then you also studied about division of physical properties. Okay, distinguishing physical property on the basis of state or function or path function. So you studied whether a physical quantity is a state function or whether it is a path function, and you also learned about their differentials. Now today I will teach you about physical quantities only. Here the difference is based on whether they are intensive properties or extensive properties. Okay, so from here our lecture starts. Today we are going to learn whether the physical properties are extensive properties and intensive. What do they mean? What are extensive properties? What are intensive properties? And which physical properties are extensive and which are intensive, and why so? Okay. Then we will proceed. Now the second topic that we will then start is thermodynamic processes. Thermodynamic processes. Thermodynamic processes we will further study. What we will further study is how changes occur. What kind of changes occur in a thermodynamic process? What variables change in a thermodynamic process? Okay, and on the basis of those changes, change of pressure, volume, temperature, whatever changes that occur in a thermodynamic process, on the basis of those changes, what are different processes named? What are the different kinds of thermodynamic processes? Different kinds of thermodynamic processes are isothermal process. You must have heard about this, right? Isothermal process, adiabatic process. You must also have heard about isobaric process and isochoric process, okay? These things you must have learned. So today this is our topic. We will learn about what are intensive and extensive physical properties. That completes our physical properties lesson. Then we will come to thermodynamic processes. And in thermodynamic processes, we will learn what happens, what changes happen to thermodynamic processes, what are the variables that change, and on the basis of those changes, what are the different types of thermodynamic processes. Alright. Then we will also learn what are reversible and irreversible thermodynamic processes. Okay, that's our third topic. Reversible and irreversible thermodynamic processes. Fine. Okay. So coming to extensive and intensive properties. Extensive and intensive properties. What is an extensive physical property and what is an intensive physical property? Alright. Extensive physical properties are those physical properties that depend on the mass of the system. On the mass of the system, or the amount of matter present in the system. Okay. Extensive properties are those properties that depend on the amount of mass a particular system carries. Such properties are called as extensive properties. And those physical properties that are independent. Okay. That are independent of the mass of the system. Very simple to understand. Okay? That are independent of the mass of the system. Now I will try to make you understand on the basis of examples. The example of extensive property is mass itself, okay? Volume, mass, volume, energy. Fine? And the examples of intensive are density, temperature, pressure, and viscosity. Okay? These are extensive properties that depend on what? Mass of the system. And these are intensive properties that do not depend on the mass of the system. Okay? Now let's come to extensive properties. Mass. Mass will of course depend on mass of the system. What is the amount of matter in a particular system? That will depend on the mass of the system, right? For example, a 2 kg ball has a mass of 2 kg. And a 3 kg ball has greater mass. It has a mass equal to 3 kgs. The constituent particles are equal to 3 kgs, and in 2 kg ball the constituent particles are equal to 2 kg. So mass is an extensive property. It will depend on the amount of mass present in that system. Then volume. Volume is also an extensive property. It will also depend on the mass of the system. For example, we take a beaker, okay? We have some water in it. And then you take another beaker. You take greater mass of water in it, okay? So here the volume is more, here the volume is less, because here the mass is more, the volume increased, here the mass is less, so volume is less. That means volume also depends on mass of the system. Therefore, it is an it's an extensive property. Greater the mass, greater is the volume. So volume is depending on mass, right? Volume is depending on mass, so it is an extensive physical property. Then energy. Energy is again an extensive property. Why? Because it depends on mass. How? See, you have potential energy, right? This is a small ball and this is a big ball, okay? This small ball has potential energy mgh and this has m-gh. The mass of this ball is greater because it's huge, okay? Its mass is greater, let's say. So its potential energy will be greater. The potential of this ball to move some other thing is greater. That means its potential energy is greater. The potential of this ball to move something is greater. Okay, its potential energy is greater. Why? Because it's huge in mass. Its mass is greater. A greater mass can exert greater potential energy. Similarly, kinetic energy is 1/2 of mv square. Mass, again mass. Kinetic energy again depends on mass of a system. So energy is energy of a system depends on the amount of mass in the system. Therefore, energy is an extensive property. Okay? Clear? Mass, volume and energy. These are extensive properties because they depend on the amount of matter or the amount of mass a particular system carries. So they are extensive properties. Now intensive property. The examples of intensive properties are density, temperature, pressure, viscosity. First I'll tell you something. Intensive properties are independent of mass. They are actually the nature of a particular system. The nature of a particular system, okay? For example, let's see density. Density is mass per unit volume, okay? So, density of a system, let's for example say, this is a piece of some substance, some metal, let's say, some piece of some metal. The constituent particles are arranged like this, okay? This is how the constituent particles are arranged, tightly packed. For example, let's say, the nature of this substance is that these constituent particles are tightly packed. That's what density is. Density is how tightly constituent particles are packed, how compact a substance is, right? How lightly a substance is packed, it's less dense. The more compact the molecules or constituent particles are packed, it's dense, more dense, okay? Density is greater. Mass per unit volume, that's per unit volume, the amount of mass per unit volume comprises the density. So here, for this substance, if you measure the density of this portion, this corner, this unit volume, it will be the same the particles will be the same dense, right? Even if you take this portion, you take this portion, or you take the whole, the mass per unit volume will be the same, right? Mass per unit volume will be the same irrespective of what amount of mass you are taking. So density is not dependent on mass. Therefore, density is an intensive property. Now mathematically I'll show you like this. Let's say for some material XYZ, this is some material. Here you have mass per unit volume. Per unit volume mass is 20. Let's say, okay, 20 kg per meter cube. For example, 20 kg per meter cube. So if you take this portion, this will again be, and then you find how many particles are here, okay? For example, in this portion there are 100 particles, fine? But then if there are 100 particles, the area is also greater, so the divided by the volume is also greater, so volume will be also a greater quantity, so that it will again come to be 20 kg per meter cube. So it does not depend on what amount of substance you are taking. Even if you take this much substance, it's the same dense. You take this much substance, it's the same dense. You take the whole, the density is the same. Fine. So density is mass per unit volume, and therefore it does not depend on the mass, but it depends on how tightly the mass is packed per unit volume. That is why density is an intensive property. Okay. Then temperature. Simple, very simple. See, what's the normal body temperature of a human body? You don't know? It's almost 98 degree Fahrenheit. Almost. Huh? So it actually depends on that standard of a country. Okay. Here usually doctors say 98 degree Fahrenheit is the normal body temperature of a body, right? The doctor does not say for a human being with 100 kg it's this, for a human being with 50 kgs it's less, for a human being with 10 kg, no. They just say it's 98 degree Fahrenheit for a normal human body, irrespective of the mass of the human body, the size of the human body. They don't say it, they say 98 degree Fahrenheit is the normal body temperature. So temperature of a system does not depend on the mass, it's the nature of a body, it's the nature of a system, okay? It's the natural property of a system. It does not depend on the mass of the system. That is why temperature is also an intensive property, okay? Then we come to pressure. Pressure is, okay, how do I tell you? Pressure we can say in two, pressure can be of two types, okay? We can explain pressure on two bases. First pressure, the pressure that we usually use in our daily language is the external pressure, right? For example, we say this is a system, and here is and we put a block on this table. Let's say this is a table, and we put a block on this table. We exert pressure on the table. This external pressure is not an intensive property. It will depend on the mass of the system. Heavier the mass, more pressure it will exert, right? External pressure. Heavier the mass, more pressure it will exert. Therefore, the external pressure, it does depend on mass, right? It does depend on mass, and therefore we can say it's an extensive property. But here in thermodynamics, because we are studying thermodynamics, in thermodynamics, pressure means something different. Pressure does not mean external pressure, right? The external pressure that is exerted. Pressure here actually implies internal pressure of the system. Internal pressure of the system, okay? The system, the portion under study, the system that we are studying, its internal pressure, its own pressure, okay? That is an intensive property. How? See, what's the normal body blood pressure of a human body? 120 by 80 mmHg, right? 120 by 80, right? It's the normal blood pressure of a human body. Do we say the normal human blood pressure for a 10 kg human body is different, for 100 kg human body it's different? No. The normal internal blood pressure does not depend on the mass. It is the nature of that body. It's the nature of that system, right? So internal pressure of a system is intensive intensive property. It does not depend on the mass, but it's the nature of that system. Okay, it's the nature of that system. So internal pressure of the system is an in here whenever we read pressure in thermodynamic system, pressure of a thermodynamic system, it implies internal pressure of the system. So internal pressure of the system is an intensive property because it does not depend on the mass. Then viscosity. What does viscosity mean? Viscosity in physical simple terms means the thickness of a liquid, right? How thick is the liquid? For example, water. Water is not as thick as honey, right? Honey is thicker than water. So we can say the viscosity of honey is greater than that of water. So if we take a glass of water and a glass of honey, the viscosity of honey is still greater than water. Now if we take 2 glasses of water, they are still less viscous than this honey. So it does not, the thickness of any liquid, the thickness of any system, of any quantity of any system does not depend on the amount of mass. It is a natural property. It is a natural property of that system. Viscosity, thickness of any liquid. It does not depend on the mass. It depends basically on the arrangement of the constituent particles, which is a natural property of that system, which does not depend on the mass. So viscosity is also an intensive property. It's easy to make out which property is intensive and which property is extensive. Okay, or the only thing here is to remember internal pressure of the system is an intensive property. Okay, so I hope you understood what's extensive and intensive property. So this completes our physical properties part, the language related to thermodynamic language related to physical properties. Now we will come to thermodynamic processes. What are thermodynamic processes? Okay. What are thermodynamic processes? Okay, one thing that I would like to tell you, if you do not understand anything, then you will just rewind the video and go back to it and then listen to it again and again. I'm sure you'll understand things. Okay, this is the benefit of online classes. I don't have to repeat things again and again, right? You just have to rewind and see the video again and again. Everything has its own benefits. Online classes also have their benefits. So if you don't understand anything, just go back and listen to that video again. Still, if you don't understand, I'm always here. You can send questions to me, no problem at all. Alright, thermodynamic processes. So what are thermodynamic processes? Thermodynamic processes are those which involve change in energy, right? Change in energy, as we learned in the first lecture. Thermodynamic processes involve change in energy. Change in the system. The system changes. How does it change? It changes from initial state to final state. That means we do something with the system, something happens with the system, so that it goes from an initial state to a different state which we call as final state. Okay, so we can say thermodynamic process occurs when the thermodynamic state of a system changes. It goes from initial state to final state, right? It goes from initial state to final state. So how do we say it goes from initial state to final state? For a thermodynamic system, how do we assess the change that has occurred? How do we know how do we know this system has gone from initial state to final state? For a thermodynamic system, we study for the changes that have occurred. We study the macroscopic properties of that system. Actually, the changes do occur at microscopic level. There are many things that occur at microscopic level, but then they manifest themselves in the form of changes in macroscopic properties that we study. Okay, these macroscopic properties that change when the system goes from initial state to final state. These macroscopic properties are called as state variables. What? State variables. These state variables are those macroscopic properties that change when that change when we go from initial state to final state. Okay. So what are these macroscopic properties that change? What properties can you think of when you think of a system, of a thermodynamic system? We change, whatever happens to the system, what properties can change? What properties can you think of that can change? Macroscopic ones. Pressure can change, yes. Temperature can change, yes. We can see a change happening in temperature, in pressure, in volume, right? In mass, right? In its composition, right? Can you think of anything else then other than these? No. Pressure, temperature, volume, mass and composition. These are the macroscopic properties that change in a thermodynamic system, okay? That change in a thermodynamic system as a result of occurring of a thermodynamic process. Fine. Now see, these are called as state variables. These processes are called these properties are called as state variables. These now when you're studying a thermodynamic process, usually you study a single component process, a single gaseous phase, for example, a single component process. क्या? हाँ? खाला को बोलो बेटा. Just give me 2 minutes, okay? Don't pause it. I don't have margin for it. Don't pause it. I'm sorry for this inconvenience. Okay. So where were we? Okay, these are state variables. All right. So when we consider these state variables for the change of a system, let's reconsider. Okay. If we take a single gaseous system, single phase, single gas system, for a single gas system or for a single component system, composition cannot change. Okay, composition will still remain the same. The state, the form can change, like from liquid to gas or from gas to liquid. Form can change, but the composition cannot usually change. So we do not usually consider composition when we study the state variables. Now we are left with pressure, temperature, volume and mass. We are left with these state variables. Now see, we can again reconsider. Take the case of volume and mass. The case of volume and mass. Here you can see, I already told you, volume is an intensive property or extensive property. Volume is a intensive property, right? Sorry, extensive property. Volume depends on mass. Volume depends on mass. Volume is an extensive property. It depends on mass. So when we are studying these state variables, pressure or temperature or volume and mass, since these two depend on each other, why not replace them with one only? Because if we know the value of one, the other can be calculated, right? Since they